In this video on volume, we're going to talk about pyramids and cones. Simply put, the volume of a pyramid or a cone is 1/3 the volume of a prism or cylinder with the same height and base. So the formula that you tend to see printed is going to be volume is equal to 1/3 capital B times H. Okay, so the idea with this is you treat it as though it is like a prism or a cylinder, except you divide that volume by 3. In example number 1, we're going to look at the Louvre Museum in Paris. If you've never been there, which I don't know how many of you have traveled to Paris, you've probably still seen it in movies. It's a big glass pyramid. The museum is actually like underneath it, and this is just like a top part where you enter it. Anyhow, it is the shape of a square pyramid, and the edge lengths are going to be 354 meters. The height, which referring to here as a true height, is a perpendicular one, is going to be 21.6 meters. So to calculate the volume, we are going to be using that formula. It is going to be 1/3 the base times the height. The base of this is going to be that square shape. So we have 1/3, and then we're going to multiply 354 times 354, side times side for base, or for square, I mean. The height is going to be 21.6. And the way this sort of works out, if you were to take out the 1/3, what you would be doing is calculating the volume of a rectangular prism. But because all the vertices in the bottom just extend to a point, you can divide it up by 1/3, and that's it. All right, for this part, I'm actually going to need to get out a calculator for it. Let's see here. I think that might be divisible by 3, so then the 1/3 is not going to give you a bad fractional number here, but you're going to get, I'll start with everything but the 1/3. So we're going to have 354 times 354. We're going to multiply that by 21.6, which is going to give you that crazy number. And then if I divide by 3, all right, so it doesn't divide perfectly into a whole number, but you do get I think it terminates at that with the 2. So we're going to get, this is kind of crazy, you get 902,275.2 meters cubed. Example number 2 is going to have us revisit the idea of an oblique figure. This is an oblique cone. Instead of having the point directly above the center of the circle base that we have here, the point is, or the top is actually just offset to a different location, so everything's getting pulled in that direction. Even though it looks different, it may feel like you should calculate the volume different than you would a regular, what we call right cone. The calculation is still going to be the same thing. We're going to be taking 1/3 as if this were a cylinder. You're going to be taking 1/3 of that volume. And our base here is going to be a circle. So you're going to need a radius, pi r squared, and then your height. Your height is going to be that perpendicular height of the 25. So we'll get everything all filled in here. This time we're looking at a diameter, which is, so the 30 is the full diameter of this, and the radius is going to be 15. The height is at 25. All right, so again, the number is a little bit larger, so I'll just use a calculator to type everything up. Some of it you could probably do as mental math, like that's 225, but after that point, 225 times 25 is a little bit large to do, so I'll just type it all in. I'll leave out the pi symbol at the beginning. Actually, I'll leave it out totally so I can just write this in terms of pi at the end. Okay, so you're gonna have 15 squared, which is the 225. That's gonna multiply by 25. So they cover you for all these numbers, and then if we divide by 3, you're gonna get 1,875. So the volume is gonna be 1,875 pi. Units are feet, so you got feet cubed. All right, now just to give you a concept, this is a nice way to write the number, but if you multiply it by pi, that's kind of gives you a better idea what it is. It's actually 5,000, well, almost 6,000 that you have here, except that this comes with a decimal. So future-wise, you'll get used to the idea of just leaving things in terms of pi.